Finally, it's time to start working on actually drawing some different graphics with our programs. Let's figure out all the steps that are necessary in order to get a window open and get us drawing on that screen. The first thing that we need in our program, and I've got an untitled window over here, is to import the Pygame library. The Pygame library makes it a lot easier for us to draw graphics onto the screen. First thing we'll do is the import right here, and this import will bring in the graphics library. The next thing is we need a little hook to allow the graphics library to set variables and otherwise get itself ready. And that's what this pygame.init command does. Init is the function name, and of course pygame. The library that we're bringing it in from. All the Pygame commands that we run are going to begin with pygame dot in front of it. Now I need to save this file. When you save the file, it's really important to remember that you want to save it not in the default Python directory, but you want to save it where you remember it. And the other thing is, this is not the file name you want to save it as. Do not save your file as pygame.py. It'll make running any Pygame file after that very difficult. You'll actually have to go through, find this file, and delete it before any Pygame file will work. Because instead of importing Pygame, it'll import this file that you just created. I'm going to do pygame_example.py for my file name. It's okay to start with Pygame as long as it's not exactly pygame.py. Pygame_example.py. Right now, all this does is import the library, initialize it, nothing's going to appear on the screen, so we need a little bit more than that. At some point we're going to draw, and this is the place where we want to put the colors that we're going to use and actually draw them on the screen. Now, colors are a little bit strange in how they're specified, but the way they're specified, once you understand it, is pretty straightforward, and it allows us to specify almost any type of color. You'll see that right here I've got black, white, and green and red, and the colors are specified by a combination of 3 different numbers. And the 3 different numbers that we've got go between 0 and 255. The colors are done like this, with a specification of how much red, green, and blue will go into making the color. And the numbers go from 0 to 255. This might seem like an odd number, but actually we have 2 to the 8th power. Remember that computers specify numbers in groups of zeros and ones. So what we have is a group of 8 zeros and ones. This would be 0, and this would be, in binary, 255. In the case of black, 000 means no red, no green, no blue. In the case of white, we have a combination of full-on red, full-on green, and full-on blue. There are actually 3 very small lights for each different dot on the monitor, a small red, green, and blue light, and these lights all together turned on will actually create the white color that you see on the screen. There isn't actually a white light on your screen, it's just a combination of these 3 colors. If you only want green, it's no red, all green, and no blue. You can find combinations for all sorts of colors online. There's a website called colorpicker.com, and this allows you to select the different colors that you would like. You can change the shade over here. If I wanted this color right here, the numbers that I would need are 61, 61, 191. You do not need to worry about these colors, the hue, saturation, brightness. The numbers that we use to specify our colors are these last 3 right here. With a combination of these 3 different numbers, you've got a lot of different color combinations that you can use in order to pick out the exact colors that you want in your program. We've got colors specified, although not too many, but enough to get started with. The next thing to do is open up the window, and that's done by this command right here. We've got two different lines of code. The first one specifies the size of the window, and the second one actually uses that variable and creates the window itself. So this right here is the width, and the second one is the height. So I have a window that's going to be 700 pixels wide and 500 pixels tall. The command to actually open up the window is right here. Granted, set mode, it really does not seem like a command to open up a window. You can actually do a lot more than open up a window if you're doing full screen games that don't have a window. This set mode can also do that. I don't really explain it here inside of this book how to do that. You can look it up online if you really want to know. Most games anymore aren't done full screen, at least in my experience, so I'm just sort of skipping over that since it's a little bit more complex, and I don't think most people will do it. The variable that we created, size, right here, is placed in here. You could actually, instead of that, just put your size directly in and skip the variable if you wanted. But I think it makes a little bit more sense, and it's a little bit easier to understand if you actually use the size variable, so I keep that. You'll also note that this is a function, and it generates a variable. Specifically, it generates a handle to the screen that we're going to draw on. It is possible for a program to open up more than one window, and then if you're going to draw a rectangle, you have to tell the program which window you want to draw the rectangle on. Most of the games that we make are only going to have one window, but we still need to keep track of that one window. This right here is going to return a handle to the window. I'm going to store it in a variable called screen. This variable could be called something else if you wanted, but just standard all the way through this book, I call the variable screen. Now at this point, I do actually have a program that will open up a window. It won't open up a window really well, and I'll show you what happens if I actually try to run this program. Okay, let's go ahead and run it. And here's my window, although I can't even move the window. You can see a lot of the windows off screen from what we've got recording, but I can't move the window on screen. I can't close the window. It just turns gray and eventually crashes if I click on it enough. The reason being, I haven't told the computer program what to do if you click on the window or created any sort of loop to help process all these events. Opening up a window by itself, not very useful. We need a little bit more. Well, the first thing that I will add to spruce up this window a bit, I want to change the title on the window. You can see the title of the window that I've got going right now, how we've got some text up here. This text is going to be set by this set caption. Now, I've created it so it'll say Professor Craven's Cool Game when I open up the window. I don't want to open up the window right yet because it just seems to crash and doesn't work really well. I need to get the interaction with the user going. To do that, I need a main program loop. This main program loop is going to repeat over and over again looking for user input and drawing what needs to appear on the screen. Let's go over the different parts of this main program loop. I'm just copying it from the book because I don't want to retype it. And it's pretty easy to explain how it works. I've started with a Boolean variable. If you'll remember back in our whole chapter on doing loops, we talked about working with a Boolean variable and a while loop, so we just keep looping over and over and over again until this Boolean variable is set to true. I started off with false. That means loop over and over until done is set to true. And right now it's set to false because I don't want the game to stop as soon as I bring it up. This is the loop control. Right here I've got the loop. This will actually loop over and over and over again until the done variable is set to true. If I let this program loop over and over again without any sort of control on how fast it loops, my game can run at almost any speed. So what I need is a clock, and this will control how fast the game runs. I'm creating a variable right now by running a function, and it stores in here a clock. I haven't actually created a control yet. What I've done is I've created a stopwatch, and down here I'm using this same clock that I created up here, and this same clock that I've created here is going to limit to 20 frames per second how fast this loop runs. If I made this 30, it's going to run faster. If I made it 10, it's going to run slower. I only want one of these clock.tick functions. So this is the stopwatch that I created up here. Whatever variable name I used up here, I need to use here. This is the function name inside of that variable. We'll talk more about that when we work with objects. And this is how many frames per second. You don't want more than one of these in your main program loop. You just want one, and you want it at the end. So let's review really quick. I've got a loop control right here that'll be set to true when the game is done. I'm looping over and over again. And to control how fast the loop, I've got a clock that I've created right here that limits it to 20 frames per second. How do I respond to if the user wants the window to close so that it won't seem like the program crashes? That is right here. This is a for loop, and it runs through every event in the game. Events would be things like mouse movements, mouse clicks, when the user presses the keyboard button. Each one of these is grabbed right here. It grabs it actually in a list. We'll talk more about lists later. But this list right here, each individual item out of that list is stored in a new variable. So I'll grab first like a keystroke and then a key click, and it'll loop over and over again for that. Here I want to figure out what type of event. If the user hits anything that would indicate they want to close the window, a pygame.quit, if that's the type of event we're working with, then we want to set done to true. When done is set to true, I'll go through all this. I'll wait my 20th of a second. I'll come back up here. I'll realize done is true, and I'll drop out of the loop, and the game will end. Yes, granted, there will be about a 20th of a second delay in actually quitting the game, but that's within the time frame that most users will expect for what seems like an instant response. If I run the program right now, it'll still seem like it hangs at the end of the game. And the reason is I haven't actually told Pygame to quit. The program just ends, but I haven't told it to close the windows and clear what it's doing. That takes one more line of code. That line of code goes down here. I don't want to have it indented. If I indent it, that means that 20 times per second I'll try to quit my game. That's not going to be good. I'm going to unindent it, so when this loop is done right here, it'll run Pygame quit. Now, if I save this and run it, my game appears. You can see that I've got the title of the game right here. I haven't drawn anything yet, so I've just got a black screen. But I do respond to close events with that event loop, and I can close the window right there. I've got a beginning of a program in order to do graphics. The next thing I just need to do is start drawing things onto it.